extrapolate the data between these two observations, that let us make this 6.5, which is between these two extremes. So that is another way of filling in the missing data. Now coming to, once the data is collected, it is clean, we got the information, the statistics can be divided into descriptive and inferential. Descriptive is basically the data which it describes. Inferential is the statistics which helps us to draw conclusion about the population. So once the data is collected, you have the data, you should be able to identify your data's scale of measurement. How you have measured your data, whether it is nominal, whether you have asked, did you like a particular thing, or do you think that interaction with Kolkata main city would lose the identity of a city like New Barakpur when it's very recent history? They would give answers in yes. You ask, what is your gender? You write no, male, female. So these things are nominal, and even if you categorize them as 1 and 2, that does not mean that 2 is double powerful than 1. Women are powerful. That is, we agree with that. The most powerful race, very powerful. But in our survey, we cannot conclude that if male is 2, female is 1, male is twice powerful than female. We are just basically categorizing it. This also goes for yes and no. Then we have the ordered data. We are putting the data in some form of order, from strongly disagree 1 to strongly agree 2, that goes to 5. So 2 is better than 1, 5 is better than 1, 2, 3 and 4. So that is kind of an order. That does not mean that strongly agree, which gets 5, is 5 times better than strongly disagree, which is 1, because there is no question of times. It is simply an order. And these two things cannot be put into, very difficult to put into inferential statistics, especially the ordinal data. Now coming to interval data. Interval data is the data that you see, for instance, temperature. The problem with the inferential data is there is absence of natural origin of 0. You cannot have a 0 when the data for which you cannot have a natural or absolute 0. 0 means there is absence. If you say how many humans reside there, you say 0. 0 means none. But if you say the temperature there is 0 degrees Celsius or 0 degrees Fahrenheit, that does not mean the absence of temperature. It means temperature is there, whose value is 0. So you cannot basically find the ratio for these type of data. Intervals data are ideally in absence of the natural origin of 0. But to have a full-fledged working 0, you need to have a ratio scale data, which is the most powerful data and most apt for any form of quantitative evaluation. They can be discrete, they can be continuous. If it is a population data, it cannot be continuous, that how many population in a particular square kilometer of area. You cannot say, sir, there are 450.78 population. 0.78 cannot be a population. If a person is there, it needs to be counted as 1. So population density is a discrete, but if you say height is say 14.71 meters. So it can be continuous. It has a natural origin of 0. Excuse me. It has a natural origin of 0. Means 0 matters. If you say 0 meter, it is at par with the mean sea level. If you say 0 persons per square kilometer, there is no population. So the basic thing we do is to find in quantification is the central tendency. I'm not going into the details, but I'm elaborating on the point central tendency. The data tend to centralize at one point. You will find, as with most of you, I know, I've heard about normal distribution now. The data centralizes upon mean. The data has the tendency to centralize on one particular value, which is typically the location of the central value. The central can be mean, can be median, or the mode. It depends upon the data set you have. The basic is the arithmetic mean, that if you have say 4, 5, 7, 9, 10, for your 5 observation, you add them and divide it by 5, and you get the simple arithmetic mean. But oftentimes arithmetic mean doesn't work. For instance, if you want to buy a smartphone and you have these data, 16 GB of memory, we have two options: 1.8 gigahertz of processor, right, and 2 GB memory, and the other with 1.5 GB RAM, 24 GB memory, and 2.2 gigahertz processor. In that case, it becomes very difficult to find the mean value of phone A and mean value of phone B for comparison, because these units are different. In that case, we are supposed to find the geometric mean. You have number of softwares, you have number of online these calculators who would produce geometric mean once you feed it. So how it is being done is secondary, but what is important is why it is being done. Why geometric mean and when geometric mean is required. The harmonic mean is required when we deal with ratios, rates or ratios. That a particular car goes 20 miles at a 65 mile per hour, then another 20 miles at this speed at 55, and next the last 20 mile at 40 miles per hour. So what was the average speed of the car? If you plus them, 65 plus 55 is plus 40, it will give you the arithmetic mean of 53.33 miles per hour. But since it is a ratio, it is advisable that you do harmonic mean, because harmonic mean produces a very true picture when we use ratios. So harmonic mean when performed gives you the value of 51.22 miles per hour, and which is less than the data produced by arithmetic mean, and we can say that arithmetic mean is basically exaggerating the value. So this is mean. Then we have median and the mode. But always remember a few principles of mean before we do for quantification. Mean, median, mode is required for basic preliminary study of your data set, your quantitative data set which you have retrieved. So these are the basic principles. That when you summation the x minus mean, you have a data set, say you have 10 data, you find the mean and you subtract this is a the value you will get is the minimum value. That you can experiment it with yourself, that you replace mean with any value, lesser than mean, more than mean, and you also compute it with the help of mean. You will find that the lowest value is produced by the value of mean. Based on the deviation, if absolute deviation, that you do not consider the minus sign, if you're not considering, if you minus it with the median value is the middlemost value of a particular data set. If you have 5 observations or 15 observations, the middlemost value is your median, the median value. So median value with x, you subtract your x from the median value. One median value you get, and you make a summation. Absolute value is you don't consider the minus sign. You make a summation. You add all the values. The value you will get after adding is the minimum value of the data set. Even if you principles to check and recheck. Then the measures, we have the measures of dispersion. I'll only focus on the variance and standard deviation. Variance is the deviation from the mean for each of the observations. You see this formula, this is summation of x minus x mean whole square divided by n. But oftentimes we find that the value of variance exceed the value of the data set. That if your data set's highest value is 75, we have find that variance exceeds 100, 200. So if your variance is not lying within the data set, it means nothing. So for it to be included within the data set, what we do, we include the square root, and that becomes our standard deviation. Standard deviation is basically works like a prison to keep your data set to keep your value within the data present in the data set. Standard deviation is basically your difference from the mean, how far you are from the mean. And then we have the quartile deviation, which is basically the quartile is you're dividing your data into 4 different segments. You have Q1, Q2, and Q3, and you find the difference between the Q1 and the Q2, the gap which exists to find how the data is dispersed. And then you have the coefficient of variation. Coefficient of variation is the standard deviation divided by the mean into 100. You may not multiply it with 100, but standard deviation by mean, it's your coefficient of variation. This is what we use. Coefficient of variation we can use. I teach my students that you collect the data, the average score in the last 10 games by Virat Kohli and Rohit Sharma, and you find the consistency. So they ask me, sir, how to find consistency? We can look at the data and say who is more consistent. We have seen the match. I say no, not by seeing. Statistically prove that they are consistent. So coefficient of variation gives you the value. The lesser the value, the lesser is the dispersion. The lesser is your dispersion from the mean. That more your data, more consistent you are, more you are within the range of the mean, more you are closer to mean. But more you are away from the mean, more inconsistent you are. So that is divided by mean. How mean dictates standard deviation. These are before going into these are some of the characteristics of measures of dispersion. Without going into this, let me move to the inferential statistics, which I say that inferential statistics is the statistics which helps us to draw inference about the population. क्योंकि पूरी population को हम सर्वे नहीं कर सकते, उनसे सैंपल को सर्वे कर सकते हैं, और सैंपल से जो इंफॉर्मेशन हमें मिलती है वो पॉपुलेशन के इंफॉर्मेशन को बता पा रही है कि नहीं, उसको देखने के लिए वी यूज इन्फरेंशियल स्टैटिस्टिक्स. इन्फरेंशियल स्टैटिस्टिक्स में 2 वर्ड्स काफी आपको मिलेंगे, कॉन्फिडेंस लेवल एंड कॉन्फिडेंस इंटरवल. कॉन्फिडेंस लेवल क्या होता है, कॉन्फिडेंस इंटरवल क्या होता है. हाउ कॉन्फिडेंस यू आर that a particular characteristics of a sample is equivalent to the characteristic of the population. How confident you are? You may be 90% confident. You may be 95% confident. Basically, we take the value of 95% confidence statistically. कोई भी अगर 95% के नीचे है, so we do not consider that as statistically significant. Confidence level we keep at 95%. Then comes confidence interval, that you are 95% sure about what? About what? I'm sure about what? I'm sure that today evening I'll be having a wonderful rain to see. Wonderful rain